welcome to my channel where we all hate J so that we just crack it and escape the matrix. This is a good question. This is from Pathfinder. It's BYU Build Your Understanding 32. So this question is a very interesting question. Let me just read the question first. A pump circulates water at a time rate q0 through a straight pipe of length L. Now a ring-shaped section of mean radius r is connected in the middle of the pipe. Inner section of the ring is equal to that of the pipe as shown in the figure. If the same pump is connected to this new pipe, how much time rate q of water flow will the pump maintain? Assume that the pressure difference at the ends of the tube remains unchanged. The pressure difference at the end means this two ends, the pressure difference are maintained. Okay, so now let's just understand this question, and I'll tell you that where the people goes wrong in this question. So this is a question. So just let me just tell you something about this q. So q is called the volume flow rate of the liquid, and in terms of but in current electricity this is also called the volume flow rate. Then this is liquid or charge and everything. This can be anything. Now this is a dot v. Okay, so uh, in this question the pressure difference in this side is maintained. I will connect this question to something analog to current electricity. Suppose this is a circuit. Okay, suppose this is a circuit. There is something in this circuit and there is a voltage difference at first. This and just imagine this. At first there is a state resistance, then I used something like this, and I ask if V is same, and I give the resistance value. This is R, this is R1 total. The Thevenin resistance is R1. Then I'll ask what is the value of I through it, right? So try to visualize something equally here. Here the pressure, here imagine that the voltage difference is equal to the pressure difference, which is actually causing the flow to happen. And there is and this thing are resistances. I mean, sorry, these things are resistances, because the flow velocity. So we have studied in just in the current electricity that the electricity flow, this I, is inversely proportional to 1 by r if V is fixed, right? Here also this q, volume flow rate, varies as 1 by obstacles, you can say. Obstacles means there is this pipe, this has something, some frictional force to it, right? So these are the things which will obstruct this flow. And what is r proportional to? R is proportional to the length of the conductor, right? Here obstacles will be also proportional to the length of the conductor. So I'll just say that think of this as an resistance, state resistance, which value would be rho into L by A, and this as a resistance of the same material, of course. This will be rho into this length, suppose L1 by A. This will be a resistance, this will be a resistance, this will be in parallel. Okay, these two resistances are in parallel, and this whole thing is in series with this and this. Just imagine like this and you will solve the problem. Because if this is if suppose this obstacle is giving is resistance as k into L, then this part will give k into its length. What is its length? Its length is pi r. This will also give k into pi r. This will give k into L minus 2r by 2, and this will also give k into L minus 2r by 2. and just like that this will be in parallel. So just the calculation part here is the calculation part. This is the P2 minus P1 term. This is KL in the previous thing, and now it becomes K into L minus 2 odd into pi R by 2, right? Then this is the V, that is analog to I. So V we get in terms of previous I, and Q naught is nothing but A into V. So if in the previous thing it is A into V naught, now it is A into V, and we put the value of V here. And we get the answer. Okay, so that's it, guys. This is a good question. This is one of the simplest question, but you just have to think analog to the current electricity here, and they will solve the problem. Thank you.